Welcome to Civil Engineering Knowledge Channel. If you people like my video, please like the video and subscribe my channel. So as many as people subscribe my channel, I will increase the number of video. So this will be very helpful for your competitive exams as well as people who study engineering. So you can see here I am going to tell you shear force and bending moment diagram. That is, so without any calculation, without doing any number of calculations, I will tell you how to draw a rough shear force and bending moment diagram. In this first video, I'll just explain you what is the condition that you can draw shear force diagram. That means only with the help of loading, how can you draw a safety diagram? So as many as you people know that writing shear force diagram is very tough. That too, in case of competitive exams, you need to solve all the calculations and then you need to go for shear force diagram. So here what I'll do is, you people here directly learn how to draw shear force diagram only by identifying which type of the load is acting on the diagram. So let us first know, the first one is no load. That means there is no shear is acting. That means you can write that as a rectangle. You can draw it as a rectangle. That I'll show it to here. For example, see. So here, okay, simply supported beam. Okay. When here there is a simply supported beam, but here the condition is no load. Here no load is acting on this particular beam. Then how can you draw? This is your reference line. Okay. This is your reference line. This is upward. So you should take upward. Here there is no load. No load means there is no shear and it is rectangle. So what I will do is, here I will draw here one rectangle because no load is acting. So it is straight line, no shear. Okay. Then it is, what they have given is, here it is upward. So from this reference line, this is upward. So this is your shear force diagram for particular example. Then they have told you the point load. That means, for example, here there is a point load. Okay. Then how will we draw this shear force diagram? How will we draw this shear force diagram? If this is your reference line, okay, so this is up, right? This is up. Then here there is this portion, there is no load. Then this is down, no load, up. Understood? So this is how we will write the rough shear force diagram. If there is a point load, then see, this is upward direction. From this reference line I'll take topward. Then here there is no load. That means here it is plain. Single line is running. That means no load is acting there. So I'll write one straight line. Then it is downward symbol. I will go this line downward. And here there is no load. I'll go straight. Here there is stop. I'll go up. This is how your shear force diagram, and this is your positive shear and this is negative shear. Okay. Next is UDL. That means, so this is a simply supported beam and here the UDL is acting. So in this case, how will we draw the SFT diagram? So this is, so here you can see this is looking like simply a rectangle with uniform load distribution, right? So here when there is a UDL, they have given here it is a triangle. But one more thing, since all the arrows are acting downward, it is a linear triangle. That means, see, so here there is a reference line, here top, I will go top. This entire portion is triangle. Okay, but triangle directly you can't draw, because here it is, if you write this diagram in this way, that is, I can show you. You can draw UDL as also like this, correct? So if you see this, all the arrows are coming downward, which means it is a linearly varying triangle. So this triangle, it comes like this. Then it is going topward. This is topward. This is positive shear, and this is negative shear. Okay. In case next it is given. See. Next what it is there? UVL. Correct. That is uniformly varying load. That I can write it as like this. That means load here acting is not constant. If you take this as RA, this is RA, B, and this as some distance X. Okay. So when uniformly varying is there, they have given at some degree parabola. That means it is at some degree. So here parabola you should draw for this. Okay. And the parabola you should draw, but here arrow mark is downward. So that is also a linear parabola. This is top, and here see, this is a parabola which is linearly going down, and this is coming up top. So this is positive and this is negative. So this is how you can draw shear force diagram only with the help of the loading conditions. Understood? So see, in this video you just understand in the sense, you should know that if in your competitive exams or during your BTech or diploma, if they have given you to find out shear force or bending moment diagram, with the calculation they will give you. But the thing is, you should know the diagram before itself with the help of loading condition. In the sense, if you see the question, that is, for example, see, this is a kind of example that I have given. They may give you this, a complex beam where UDL also will be there, point load also will be there, 2-point load also will be there. In this type of a beam, if they have given you, you can directly draw shear force and bending moment diagram. So that is what I am making you easier here. If you know this part of loading condition, you can easily draw the shear force diagram. This is one of the technique you should remember of. Okay, if there is no load, then there is no shear, it will become a rectangle. If there is a point load, then there will be an vertical line. For example, as I told you, if this is a simply supported beam, if there is a point load, what will happen? At top there is no load, straight line. See, this is a concentrated load, then it comes a vertical line. There is no load, again it is top up. So this is point load, means there is a vertical line. UDL, that means this will be in the form of arrow pointing downwards. So if there is a triangle also, it will come linear triangle. That means linearly it is going. Okay. So because why it is going from top to bottom, for example, see, as I told you, if there is a UDL, why in this it is going top to bottom, this triangle? That is because all the arrows here are downward. In UDL, all the arrows will be pointing downward. So that is the reason it will come like this. Okay. If there is UVL, it comes parabola. Okay. So this is about this video. I'll explain with some more examples according to these type of the loading condition. How can you draw bending moment diagram? Shear force diagram you came to know now. Bending moment diagram I'll explain in my next video. So on the third video I'll explain complex beams with shear force diagram and bending moment diagram. If you want all those this part of the video, you need to subscribe my channel, or else you are not going to get any kind of the videos. Okay, thank you.